Hi guys, my name is Ajit and welcome to my YouTube channel. So today we're in part 20, finding best feature and split value for decision tree from scratch. So if you are new to my channel, then I have already created Android and Coursera machine learning in Python, and I have written several equations from scratch, and I'm still writing these equations. So in if you are new to my channel, then I would recommend you to please subscribe to my channel. So let's start. In the last video, in part 19, we discussed about decision trees, and with a sample example on COVID-19 data, we wrote machine learning equations that involves the entropy, Gini index, information gain. So if you are not familiar with this topic, I would recommend you to my part 19 video, which is here, part 19, this video you can watch. So in this video we will discuss on finding best feature and speed value. So a quick recap on part 19. So I have used iris data set. So this is my x variable I have stored in x, and y, my target variable in y. Since my y variable contains a numerical value and I want to represent this in a tree, so I thought of converting the numerical value to categorical so that it becomes visible in a tree. So I have converted this to a tree, to a categorical value. So I have used a lambda function. So if my y is equals to 0, then I have populated iris sitosha. Else, if my y is 1, I have populated iris versicolor, and else iris virginica. It's very difficult for me to pronounce this word. So it's like converting. I have converted the numerical value to categorical. Why I have converted? Because if I want to visualize this information in a decision tree, so I have converted this into categorical so that it becomes visible and clear in a decision tree. So this is stored in an array. So we need to convert this into numpy vectorize so that we can convert this from numerical to categorical value. So, so if you see here, the top five, so it has been numerical value has been converted into categorical. Then we loaded this value in a data frame and added a new column and converted this label as a category, and also stored the information in array. So in we have both information, one in array as well as in data frame. So why did we do this? Because in decision tree, so all the algorithms that are written in decision tree are based on numpy. So we didn't use pandas data frame because it was very slow comparison to numpy. So I will be writing all the equations based on numpy, not on the based on pandas. So I will be using data. This data contains the all the records of IS data set. So I will be using this data to write all machine learning equations. So in label we have three values now. Okay, so this was the part we did last time, and I'm just giving you a quick recap. So this was the visualization that we did, and this is the line that distinguishes the purities and impurities of data. So data that is below zero point 0.8 doesn't have any impurities because we only have one class, one label, which is Sitosa. So the value greater than zero point 0.8 have the maximum randomness because it has two classes, right? So then what we did, we split our data. So we did a split so that we can, so on basis of this diagram, my split will be 0 0.8. Okay, so by using 0 0.8, why I chose 0 0.8 is simply to denote the impurities. How much impurities will I get once if I use uh, a pedal width of less than 0 0.8, what would be my entropy and what would be my probability. So for that I have set one threshold, one line to check the entropy and Gini index. So to split this data, I have written a split function where I will pass my column name. So column name is my third column. Third column is petal width, right? So if you look at df dot head 1 2 3, sorry, it's petal length 0 1 2 3, so it's petal width here. So on the basis of petal width, this will be my column splitter, and split value will be my 0.8. Why I chose 0.8? Simply to check how much entropy or probability I get in this data set. Okay, so this was the split data. Then I chose the third column and my split value is 0.8. On basis of that, I have splitted my data and below and above. Yeah. So if we look at the below, here you can see it's less than 0.8, 0.2. You can see in this column 0.2. So this is below. And if we check above, you can see it's greater than 0.8, right? And this is a third column. This column is first, this is second, this is third, this is fourth. Okay, then we calculated entropy. So entropy gives us the amount of impurities in our data. So these equations I have already written in my part 19 video. So I'm not, so you can see these equations in more detail in my part 19 video. So after calculating entropy for data below, you can see you have entropy of 0 and probability is 1. That means you don't have any randomness. We don't have randomness in your data because you don't have anything to split below 0.8 in this figure. Likewise, if so, what would be your interpretation is, as we see entropy as 0 and probability of 1 for data below. This tells us that we don't have any impurities or randomness in the data because we don't have anything to split. If we don't have anything to split, that means that data is pure and we don't have randomness in the data. Then we checked the entropy of value that is above 0.8. Above 0.8. Data underscore above have that value. Then here we see here we see entropy of 1. This is the maximum entropy that we can have, and that is on probability 0.5. So my entropy always ranges from 0 to 1, and maximum entropy will have when my probability is 0.5. So at 0.5 we will have maximum entropy. So as we see entropy as 1 and probability of 0.5 for data above, this tells us we have maximum impurities or randomness in the data for data above at probability of 0.5. So Gini index even gives you the same result. So these equations, if you want to learn in more detail, I have explained in my part 19 video. So this is the Gini index. So Gini index below, data below, you will see 0, and in data above you will see 0.5, right? So above 0.5 has the maximum probability. That means that that tells us that we do have maximum impurities. We have maximum impurities here in data above. Data below, we don't have any impurities. So the difference between Gini index and entropy is Gini index at probability 0.5, the Gini index is 0.5, right? Whereas at probability 1, the entropy is 1. So we have explained this via diagram in part 19 video. Okay. So also the entropy involves log transformation. It is computationally expensive compared to entropy, compared to Gini index, sorry. So information gain assists us to determine which feature to use to split the data, right? So in last video we looked at an example of COVID-19 data, and checked the entropy and checked the information gain based on two feature and fever, and we were able to determine the highest entropy was seen on fever. So in this way we were able to figure out that the figure with figure fever fever will be our first feature to split the data. Okay? So highest entropy gain will be our first feature to split the data in distant ray. So which was fever. Okay. So this till this part we did last time. So in today's part, our task is to find best feature and split data in decision tree, right? So for that, what we need to do, what we need to know is we will find four things here, right? First thing would be to check purity. Check purity means in this node, in this tree, this is the pure node. Okay, why this is pure node? Because we don't have anything to split our data further, right? So we don't have anything to split our data further. That's why this is a pure node. So every leaf node is a pure node. Okay, pure node means no impurities or randomness. We don't have any impurities or randomness on leaf node. Okay, so first one would be, so first function would be to check impurities, right? So if we don't have any leaf node, then that would be my pure node, and I don't need to split any data, right? So I will create one function that will check purity. So if we don't have any leaf node, if we don't have anything to split, then I will return true, else I will return false. So check impurity will check the boolean value as true or false based on dependent variable, that is in my case so I have data here. So data contains, let me say, so my label, so I will check impurities based on dependent variable. So dependent variable is iris sitosha. Okay, so based on this variable, if I don't have any split, so if the count of this iris sitosa is 0, then I will return true, else I will return false. So if we look at set of -1 will give you the last column, right? -1. So you can see here, so we have three values, okay, which means it can be splitted, my data can be splitted either in these three labels. Okay, so I will check my impurities and I will return true if only I have one label. If I have one label, that means that is a leaf node, I don't need to split anything. Okay, so here my data will be, so first I will take the last label. So this is equals -1 will give me last dependent variable. This will give me dependent variable. -1 means take last feature, which in our case is dependent variable. Okay, so I have taken, so let's say this as dt. Okay, I pass this as data. Okay, now I will take unique value. So I need to take unique value. Okay, so for that I will use np.unique. So this will be my first value. Then I will use np.unique dt comma return underscore true is equals to return underscore count, sorry, not true, count equals to true, not df, it's dt. Yeah, so this gives me the count. So I have 50. So here you can see 50 value for this. For Sitosa, you have 50 records, and for versicolor, you have 50 records. Okay, so this is my first array, and this is my second array. So this is my 0, and this is my 1. Okay, if I give here 1, this will give me the second value. Okay, so I will store this unique value in a variable. Okay, so this is my unique count. Count this value. Okay, so if so let me store both unique count and unique value, both unique value as well as unique count. So if my length of unique value is equals to 1, that means I only have one label. Okay, either it's Virginica or Sitosa or versicolor. If I only have one value, then I will return true. That means I don't need to do anything else. Return false. Okay, this will tell me whether my data is pure or not. Okay, so first one, okay, last column, and this will give unique value and count. Okay, to check purities. This is my first function. So right now if I run this, then I will get false because I have more than one distinct values, right? I have Virginica, Sitosa, and versicolor. Okay, so if I use 1, let's say equals let's say I store this value in one variable. Okay, now this value only contains, if you look at set value, -1. Okay, so it only contains one value. Okay, so now if I check the purity of only one value, it should return true. I mean this. Okay, so this returns true, and this returns false. So this contains only Virginica. So if you check for only Virginica, so this one true because it only has one value. So this is working fine to check purities. So only one node means will return true, else it will return false. And then based on this value, we will take maximum. Just for example, if this returns true, true or false, we will take the maximum value, maximum count of our, so that we can make a classification. We'll discuss why we need classify data later. So my data will be again, say this as data. So data will be equals to NTF. So to take, this is to take last row, we will take unique value, and unique count, and then finally we will take maximum of unique count. Okay, so if we check this, then here if we look at the unique value, so all three are equally distributed. So if we take np dot arg max, so dot arg max of count, this will give me the maximum count, and np dot arg max, np dot arg max count underscore value. Oh, so it should be tt, sorry. Let me run this again. So the count is this. This gives me the index. Okay, this gives me the index, and then I need to give this. This is the first Virginica. It can be any because all three have equal count, so it can return any value that has highest. So in our case, three three labels, three had highest value, so it can return any label. Okay, so yes, let's consider this as class C5. Let's paste this here, and then return classify. So this will return me, this will return the highest count. Let's check classify. Okay, so this is fine. Now the third step would be to split data. So we need to split data to get the answer. Like decision tree works on splitting data based on yes or no answer. So we have already written this split data function, so we will copy that. So this is a split data function, and then Guinea and entropy, even we have written this function in part 19. So this is entropy, and this is gain function. Okay. Now what we need to do is we need to find overall entropy. What does overall entropy means? So right now in part 19 video we find the entropy of the first node. This is a root node. So we found the entropy of root node, but we also need to find the entropy of this splitted node, right? So this splitted node will have probability. So we will need to calculate. We will add this probability. This will be my prior. So prior probability, prior entropy plus probability of this probability times the splitted node, splitted node plus probability times left splitted node, probability times right splitted node. Yeah, so we need to find the overall entropy. So overall entropy will be based on the data below and data above that we get from split data. So split data will give me the data below and data above, and then we will find overall entropy. So new entropy will be new entropy entropy comma need to leave blank because we don't need probability. So we will calculate entropy for the data below. Okay, new entropy for below, new entropy for above, or data below, data above. Also we need a probability of below. So probability of below will be length of below divided by length of below plus length of above. Okay, so my total probability will be, overall entropy will be, so probability times probability of below times entropy of below, entropy of below plus probability of above times entropy of above will be my overall entropy. And the lowest entropy will be the best split value and column. So we can either take the lowest entropy or highest information gain. Both are similar. Okay. So in today's part, we will take lowest entropy or lowest Gini index. So we can take any. We can take either lowest entropy or lowest Gini index. This will give me best split value and feature. Okay. Else we can take other or we can take highest information gain. It's up to you what you want to do. I will take a lowest Gini index. So new Gini will be probability of below equals probability of above. So length of above, and finally my overall entropy, probability of below times entropy of below plus probability of above times entropy of above. Let me check if this is correct or not. Yeah, this looks good. Let's return overall entropy. This gives me overall entropy. So data below and data above is retrieved from split underscore value function. Okay, this will give you your entropy for data below. This will give you entropy for data above. This will give you probability for data below. This will give you probability for data above. This will calculate overall entropy. So it is very important, guys, to give right comment in your code is very important so that everybody can understand. So this will be my Gini index. So always write comment in your code. This time this will be my Gini index. Probability will be same. Below. So below, above should be here. Above. This is overall. Okay. Let's check if this is working or not. It's working. Now what we need to do is we need to write a function to calculate potential split. So why we need potential split? Because we need to split data, right? So we need to split our data. So what can be a potential split here? You can see the potential split can be the mean of these 2 points. The mean of this orange point can be your potential split. So for every point, your potential split will be your mean. And see here, every point your potential split can be the mean of these 2 points. Okay, so we will calculate potential split so that we know that what split we need to make. And once we have a potential split, on the basis of that potential split, we will decide to calculate entropy. And then once we calculate the entropy based on the potential split, we will take the lowest entropy that will give us the best feature and best split value. So let's write a function to calculate potential split. So potential split we need would be the mean of these 2 points. So you can see this line is the mean of these 2 points, right? So let's write a function that gives us the mean of 2 points. Okay, so for that we need to store the feature as well as the mean value. So for example, so we need to store the pattern width and all the mean value, all the mean value 0 0.2, 0 0.3, it can be, and so on. It can be in a list. So we need a dictionary, right, to store the feature name and the mean value, right? So we'll create one dictionary first. So let's give a dictionary name like potential split data equals dictionary, right? So my data will be on the basis of dt will be data of last column, a dependent variable -1. So I need to exclude the dependent variable. So here what I did, I excluded. So if you check here, if you check top 5 dt, I have excluded my dependent variable because I don't need to have dependent variable. So this split should be on the basis of independent variable, that is all the feature, right? So I have excluded my dependent variable from here. Then I need to loop all the features, right? So my columns will be equals to dt dot shape of 1. So shape of 1 will give you all the features. Okay, so if you look at columns, so I have 4 features in my data. Okay, so I will loop in all the features, column index, new columns, and then so once I loop in all the index, let's say, then let's calculate a feature, and then I will pass all that feature one by one in my column on the basis of column. Okay, on the basis of, so this will ones will have 0 2 1 2 3 4 to 4. Okay, and then I will take unique value of dot unique of feature, unique value of one feature, and I will store this column index right now as a blank. Okay, so what till now what I did, So I computed the unique value. I splitted the columns. So for 0, 1, 2, 3, this will go in here, and then I took unique value. Okay. So all unique value is stored in this variable. Okay. So now for index in unique value of unique value range. So your current value will be unique value bracket index. Okay. And your previous value will be, why we are taking previous value and current value, so that we can calculate average, right? Previous value index -1. Okay, so I even need to give the condition like if index is not equals to 0, because we are doing here -1, not equals to 0. Now, so now my potential split will be equals to current split plus previous split divided by 2. Okay. Now I will store this value in dictionary. Okay. Here. Dot append. Okay. So this, in this way I will be able to store the mean of each feature. Copy this here, paste, and then here I will return potential split. Let me check if this is working fine or not. So it's not working fine. There is some problem here. So if index, this looks good. This should work fine. Yeah, it's working fine. Let's see. 3. Yeah, it's working fine. Okay. Now let's let this. Now if we visualize this potential split data on the basis of tree, which is petal width, you can see here potential split. So we can see the mean of two value is drawn here in a vertical line. Okay, so now we got potential split. Now our task is to find the best split based on potential split, and then we iterate over potential split and then take the lowest Guinea index, which will be our best feature. Yeah. So here to store feature name and mean value, we created dictionary. This one to exclude labels. Bracket dependent variable. This one to iterate over each feature. Each feature. Say if one will give us value, one will give features. So this one is for iteration. This one is to iterate each feature again, and then this one is to take unique values, to take unique unique value of a feature. To store feature in an empty list. Okay, again we do iteration to get this one, to get current value, this one to get previous value, this one to get mean value, and finally to store in a dictionary. Finally we have in a dictionary. Okay, and then we did visualization. Now we will find best split based on the potential split. Okay. So we'll find best split based on the potential splits result. Okay. So potential splits will be here. This is a potential split. Now we'll iterate over each for column name in split columns. We need to iterate for values. To iterate values in for each column, value of each column. Okay. So once we have the value of each potential split, we need to divide our data. So we need to split our data. So here we split our data. So data below, comma, data above. So split column will be this column name, and value will be this value. Index value. Now we calculate the current overall Guinea index. So overall Guinea index will be on the basis of data below and above, which we have already calculated. Below and above. So the smallest value will be our best feature and best value. So let's create a variable. So overall Gini index, let's set it to 999. So use value. So if any index this is less than the current value, then the overall value will be equals to current value. In this way I'm going to get the my best feature will be equals to column name and first underscore split underscore value will be this value. So we will compare this with overall Gini index, and we will store this value in overall Gini index. So in this way we will iterate over all the value until we get the lowest Gini index. Once we get that, then we will store our best feature as column name. That would be my column name, and split value will be my split value. Okay. Mm, This will be inside the loop, and then outside let's return best feature const file. Okay, here we go. So this is my best feature, and this is my best split value. So this is to check and compare the Gini index, and compare the Gini index in order to receive lowest value. This is the split data. Split. This is to calculate overall Gini index. This is to check lowest Gini index. Okay. So finally, in the data, we found that the first feature is pattern width, and your first best split value is 0.8. On the basis of this feature, we will split our tree. So in the next video, we will complete this algorithm for decision tree, and we will even do a visualization of decision tree. So that's it for today's lecture. Hope to see you next time. If you like my video, do subscribe my channel. Thank you so much.